I'm sitting here today with Carl Staub. He is the grand poobah of Agtron. Agtron, as everybody knows in the coffee industry, is the standard maker for the chromatic scale of coffee roast. Hey, Carl.
Hello.
Tell us about Agtron.
Well, 1986, for commercial coffee companies, we introduced the idea of analyzing roast development based on chemistry and not color. Cuppers see the Agtron number, they taste the coffee, and they agree with the numbers as far as the development is concerned. Not a color analyzer, totally blind to color of the coffee. Turns out color is a very low resolution way to determine development. But it does look at a chemical constituent in coffee called quinones, quinone compounds. Those are directly related to the organic soluble chemistry, and that's why it's such high resolution and why it's been so widely accepted.
So the quinones develop when you apply heat to chlorogenic acids, doesn't it?
Well, there's two kinds of reactions that are occurring in coffee. The Browning reactions are principally Maillard reactions. Any kind of a food where there's a protein, water, sugars that you heat and they turn color, they turn brown, those are Maillard reactions. So what you see in coffee is one thing, but you can't see the chemistry of the coffee unless you use a piece of analytical equipment.
One of the things that people misunderstand so much about the concept of Agtron, of the Agtron analyzer, is that it's not only the exterior color but also the interior color, and it's the relationship between those two.
Right, we always like to have our customers look at the ground sample. You can look at whole bean, the outer surface of a roasted coffee bean represents maybe 3% of what's going to end up in the cup. But you grind the coffee, you get a good cross-section of the chemistry, and that's what we want to see, because that's what's totally going to influence the character of the cup.
How did your method of measurement become such a standard?
I think probably there was a lot of influence in the early days from commercial coffee companies. This was a very small organization, and coffee, unlike, say, the wine industry, I'm going to make an analogy, the wine industry has embraced science, and they're probably many, many years ahead of coffee. When I first got involved in the coffee industry, I'd ask companies that were roasting incredible quantities of coffee why they were doing certain things, and they didn't really know. And I thought that was a great opportunity to get more involved in not just, measurement and standards, but also in getting a better understanding of the function of roasting, why coffee is such an engaging beverage for human beings, why we like it so much, and how could it be improved with science. So I think SCAA was at a time when they didn't really have too many standards. Probably Dr. Lockhart's work and Ted Lingel's work with the CBC back in the 60s were a few of the standards, other than some simple color guides for roast development, and I think it was just the right timing. And the device worked. I remember some of the great minds in coffee at the time were sort of adverse to using a piece of analytical equipment. Their idea was, if you can't tell how roasted a coffee is, you shouldn't be a coffee roaster. Most of those people use the Agtron analyzer now. I won't mention names, but it's kind of great. And we're in 39 plus, maybe more countries now. I'm amazed when I go to a place like the Colombian Coffee Federation.
And they have
in a lab out in the middle of nowhere, and they have an Agtron analyzer. Yeah, it's kind of cool to see that. So we're going to calibrate the analyzer. This is the Agtron E20CP. This is the analyzer most widely used around the planet. Push the calibration button. I'm going to use a synthetic standard to do the calibration. The standard has two sides to it. One that represents the lighter roast, and another side that represents the dark roasts. We'll introduce that to the analyzer. When I open the drawer this time, the analyzer is looking at another disc that's under the drawer, and it's going to store that reference for future calibration. So I do this, say, at the beginning of a shift of the day, beginning of the day. Once that's finished, then I can introduce the standards or the samples to be evaluated. These are ground samples, and we use a straight edge to make a flat conformal surface. This is a good representation, an average representation of the chemistry in the coffee. We're looking at a very large area as well. This is really important. Gives us a better idea of what the roast development is. Analyzer's taking the measurements right now using 3 specific wavelengths of near infrared, and it comes up with a score. The way the scale works, 0 would be if you thermally degraded all of the organic chemistry in the coffee, it would be carbon. It would have no smell or taste. And 100 on the scale, the Agtron scale, would be a point where 3 to 5% of the sucrose by weight had fractured. That's where the first crack occurs. If we were able to stop the roasting process instantly at that point, we will grind it, extract the chemistry, it wouldn't be a commercially viable coffee. It would be very, very undeveloped as a roast, but you'd know, everybody would know it had the quintessential characteristics of coffee. So you'd be able to identify it as coffee. So that was a 49.2, which is a medium, sort of a medium roast. And then we're going to look at a lighter roast. This one's going to be 72.6, so that would be a light roast. That's all there is to it.